quick tutorial on how to use a plot digitizer. This is an immensely useful tool when you are analyzing your own data and comparing your data to other published data, where you often don't have access to other researchers' raw data, but you need to process it in order to understand your own data or contextualize your own data. So this is an enormously useful tool as you continue your research career. So you can just navigate to plotdigitizer.com. There's a pro version, as always, but the free version will work for most things. So you'll be presented with this screen where you need to add your data in an image format, which means just take a screenshot and save the piece of data, the figure typically, that you'd like to digitize and extract the data in numerical form. So in this example, I will grab an XRD pattern, and I've already got it saved as a JPEG, so I'll just open that up directly, and I get something that looks like this. So next thing, you can see these four different colored dots, X1, X2, Y1, Y2. Those are just tossed randomly in the middle of the image that you uploaded, and then you can see in the top right, as I scroll around, I get a zoomed in version with a crosshair. So what I want to do is take my X1 and I'm going to click and grab it, and X1 refers to the X-axis, and I can grab it and put it on any point here, and all we're doing here is calibrating how many pixels correspond to the actual numeric value of our X-axis. So I'm just going to, it makes most sense to start here, but you don't have to. And I will drag my X1 there, and then over on the right where it says X1, I'm going to type 20 because that's the numeric value associated with that point. And then I'll do the same for X2. I could grab it and put it at 60 or 70 or whatever. It's just using that distance to calibrate itself, but I'll just put it out here for good measure at 100, let go, and then type in 100. Now I've calibrated my X-axis, and I have the option of choosing a variety of different things here, and I want it to be a linear axis, but if you're doing a logarithmic axis, you could tell it that. Now we'll do the same thing. Where does my y-axis start? In this case, we'll just say that the y-axis starts down here. You could have it start up here because it's non-numeric, it's normalized data. And so we'll just say that y1 is 0, and if this is normalized data, then it doesn't really matter what value we put up here, but typically this is 1. So that allows us to now, as we hover over this, you can see that I have actual XY values with tons of digits associated with it, which can be enormously helpful if I want to digitize these data. So one thing I could do is I could go along and click these points for my actual data, and I could just manually click along every single point, and I could take my time if this data was really important, right? And then what I get are X and Y data points, and I can just copy and paste this into Excel and then replot this as the actual data. That's incredibly useful. Or in the case of, say, wanting to use this X-ray diffraction pattern to maybe just extract what is the exact position of these peaks, well, that's pretty handy because I can just zoom in, look at my zoomed in image, find that point, click it, and now I know on my x-axis that corresponds to 39.53 degrees to theta, rather than just sort of ballparking the number. I have a more accurate number. Similarly, if I want to do crystallite size analysis using the Scherer equation, I need the full width at half maximum. And so I could look at what y value this corresponds to, which is 0.86. I could look down here at the bottom at the y value, which is roughly 0.24. I could say that the difference there is roughly 0.62. So the whole height is 0.62. So really I would need to go from 0.24 up roughly halfway. So I could compute that, or I can just ballpark it and say that's roughly half. Click a point there, go across half, and line it up, click a point there. Now the difference in X here, that's the full width half max. So I could do the same thing, grab the 200 peak, go up halfway, grab my left bound, my right bound, there, take the difference, there's my full width half max, etc.